Welcome back. This is the second video for Chapter 7, or Arrays. And in this video what we're going to do is look at how to declare and create arrays. Later videos we'll talk about primitive versus object arrays, how to process them, using them as parameters and return values, and sorting and searching. So, before we get started, what's the difference between declaring and instantiating a reference variable? Because those are two separate things, two technical words, and we need to know what each one of them means. So declaring a variable that's a reference variable means that I set up a box that's going to hold an address, but it doesn't refer to anything yet. So in this line of code, string s, I've declared a string reference variable. That means I have a box set aside somewhere called s that can hold the address of something in memory, but it's not referring to anything yet. When I instantiate that variable, that means I make this reference variable point to its object. Okay, so now this reference variable actually refers to something. So it's a similar idea with arrays. We need to know how to declare them and how to instantiate them. Let's start with declaring. So, since arrays are objects, what do we have to use to refer to them by? Ooh, I just gave it away, didn't I? I used the word refer. So we have to use reference variables to refer to arrays, because arrays are objects. Well, think about what we just did with the string example. Declaring array variables is just like declaring other reference variables. We have a pattern for that. We have the type of the variable and then the name of the variable. Okay, like string s, or int I, float ball x from the solo pong example, p-image, img. Now that's a reference, right? That doesn't point to any image yet, but it is a reference variable. Or audio player, player. Now player is a reference variable to an audio player object. That object doesn't exist yet, but that's what this variable will hold. Okay? Now specifically for arrays, we can create arrays of anything in processing. So that means that there can't be a built-in array type for us, because we can actually define our own classes in processing, and therefore we can have arrays of those types of objects. So there's no way that the developers of processing could anticipate all the types that might be created. So instead, to declare an array reference variable, we use that same pattern, type and name, but we add square brackets to the end of the type. So like this. Whatever my type is, this is the type of thing that's going in the array, empty square brackets, which indicates that that is an array and not a scalar or single variable, and then the name of the array. So some examples. Here is a way to declare an array of integers. So the type of thing in the array is ints. Square brackets mean that it is an array of those things, and int array is the name of the array. Float array. So this is an array of floats. Here's an array of p-images. So this would be an array of p-image references that would point to p-image objects. Here's an array of strings called names. And again, this would be an array of string reference variables. Okay? So whatever the data type is that you want to hold in the array goes first. Square brackets means that now it's an array, not a scalar type, and then we have the name of the variable after that. Okay, now how about creating them? In other words, how do we make the things at the end of those links? How do we instantiate arrays? Well, arrays are objects, so we follow the same general pattern we used for creating other objects. Whatever my variable name is, this is the reference, is set equal to the new keyword, then the type again, and the square brackets. But now we'll put a size in between the brackets to tell how many of those elements the array should hold. And just like we saw with other objects, we can combine the declaration and creation or instantiation with one line where we declare the variable over here and then create it over here. Okay? So let's take a look at some examples, and then we'll come back to the slides. So let's see how to declare and create some arrays here. Let's start with an array of 20 ints. Okay, and in this case I'm going to declare the array variable first. So int 2 square brackets, that means that this reference variable is going to be an array of ints, and I'll just call it ARR. Now at that point the array doesn't actually exist, I just have a reference variable to it. I can create the array itself with the new keyword, and again when I do that I reuse that square bracket notation, and inside that square bracket I have to put something that evaluates to an integer, and that will give me an array of that size. Okay. Now let's take advantage of the print line statement, which is a good way to debug or test programs. And what that will do is just cause a variable, or whatever we put inside the parentheses, to be printed in this area of the console. I've enlarged it so it's a little bit easier to view. If I run this program, oops, I'll put an exit in here as well so it will finish. There we go. So there is an array of 20 elements. They're all listed out. The things in square brackets over here are just the element indices. These are the values. Okay? Notice default values. Now what if we want to make an array of, let's say, 5 floats? I'm still going to use that same variable name. And now I've created an array of 5 floats. And notice that I declared and instantiated the array all in one line in this case. Run my sketch, and there's my 5 float values. Again, default values. And notice that the indices always start at 0. 0, 1, 2, 3, 4. Now what about if we do an array of objects? So let's make an array of 13 strings. Okay, again we'll keep the same name, but I'm going to call it string, or make it contain strings rather than floats, and it'll have room for 13 things. Now look at what we get. Null, 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 null. Okay, so the defaults are a little bit different. Now it's important to notice that arrays are filled with default values when they're created. So we can always count on processing arrays to be filled with false if they're arrays of booleans, 0 for everything else, integers, characters, etc., or null if we have object arrays. Okay? So those are our default values. False for booleans, 0 for primitives that aren't Boolean, and null for object references. Okay, now in certain situations, when you know the values that will go into the array at the time you write the code, and you know that there aren't that many values, then we can create, instantiate, and initialize non-default array values all at the same time using this syntax. In this case, we don't have to specify the size because that's apparent by the number of things that we list in the curly brackets. So again, let's go and take a look at some examples where we create, or declare, create, and initialize to non-default values all in the same line. Okay. Now we're going to go ahead and show how to create, declare, create, and initialize all in one line. And so this really is only appropriate when you don't have that many elements, because I have to list them out all separately. inside curly brackets. So now if I run this program, you'll see that my array elements are listed here and they don't have the default values. Okay. We could also do that with strings. So if I make this an array of strings instead of integers, now what I have to do is put strings inside the initialization list. Okay, so now I have 4 strings, and when I run this, notice that I get hi mom, hi dad. And for some reason, processing displays object arrays differently than it does primitive arrays, but nevertheless they are printed out down in the console area. One last piece here regarding how to create arrays, and that is to notice that the size inside the square brackets does not have to be a literal. And that means that the size of the array can actually be chosen at runtime. However, once we create that array, its size can't be changed. So once an array has been allocated, we've created it with the new keyword, put some values in it, whatever, we can't resize the array. Now what we're going to do is look at how to create or set the size of an array that we're going to create at runtime. So I'm going to do a little bit of dialog box input. Okay, so that should give me an integer. And then I'm going to make an array of strings that is based on that integer. And let's see what we get. So if I enter 5, I get 1, 2, 3, 4, 5 things. And you know what? I think I'm going to change this to booleans, just so we can see the array indices. Now run this again, and let's suppose this time I need an array of size 15. Well, there we go. Or suppose this time I need an array of size 1,000. There I go. Okay? So we can use that technique to make our programs adapt dynamically to conditions. So the arrays can be created based on things that happen at runtime. We don't need to know their size when we write the code. And that's extremely powerful. It's kind of a concept called dynamic memory allocation. Super important. All right? Very good. So now we're going to go ahead and end up here, and then we'll cover the idea of primitive versus object arrays, and then start to talk about how to process them in the next video.